Hello students. So now we'll start the clock and instruction cycles. Instruction clock. So what is the instruction clock? Clock from the oscillator enters into a microcontroller via oscillator pins, where internal circuits of the microcontroller divide the clock into 4 even clocks. Okay, so all the clocks are divided into 4 even clocks, and Q1, Q2, Q3 and Q4 we can make them as its name. So these 4 clocks make up one instruction cycle. So these clocks, all 4 clocks can be divided into can be said as one instruction cycle. So here you can see that one clock, this Q1, Q2, Q3, Q4, these all clocks are, this is a single clock, and this clock is divided into 4 clocks, 4 equal clocks, and these 4 clocks are defined as a one instruction cycle. Okay, so execution of instruction starts by calling an instruction that is next in string. So instruction is called by the program memory or on every Q1. So when Q1 comes over there, then an instruction is fetched from the memory and is written in the instruction register on Q4. So what happens actually, at the starting of the Q1, the instruction starts to fetch from the memory, and till the Q4 the instruction is written to the instruction register. So here is the instruction register, so the instruction is written on the instruction register. Decoding and execution of instructions are done between the next Q1 and Q4. So here you can see that decoding. So what we have, instruction is a decoded form of to do any task. Okay, so coded form of doing any task. So after fetching this coded information, then decoding is over there, and then execution of the instruction has to be done within the next Q4. Okay, so here in the first Q1 to Q4 is to fetch the instruction from the memory. Next Q1 to Q4 is to decode and execute instruction. Okay, on the following diagram we can see the relationship between the instruction cycles and clock cycles, clock of the oscillator as well as that of the internal clocks Q1 and Q4. So internal clocks are Q1 to Q4, and these instructions are need to be the instructions are fetched from the memory, and then then at the next Q1 to Q4 it is decoded and executed. So program counter holds the information about the address of the next instruction. So program counter, you know that program counter holds the address of the next instruction. It's a you can say that it always has the same manner in every microcontroller or microprocessor. Okay, pipelining in the PIC. So pipelining structure is provided in the PIC, and more fast execution can happen in it. Okay, so here T cycle 0. So here already you know that T cycle 0 or T cycle 1. So it means that there are 4 equal clocks are available for the operation. So for this also there are 4 equal clocks are available for the operation. So this is an example of a code, and this is the micro code, and you can say assembly language coding. And here move LW55H. So move LW is the lower word. It's for the lower word, and here is the data. It is need to be put in a LW register. Okay, so in the first T cycle this instruction will be fetched, and in the T cycle 1 it will get executed. But in this clock cycle another instruction will be fetched. Okay, and then in the next cycle next instruction will be fetched, and then first instruction will be executed. Okay, so likewise this all the instruction will be executed in this instruction set. So it has the two-stage pipeline. First is to fetch and another is execute. So here is the program memory of the PIC microcontroller. So technology is EEPROM, flash or ROM. So this type of memories are used for the PIC microcontroller. It varies in size from one chip to the another. So 12C508, 512 and 12-bit instruction. It has the 12-bit instruction. So it has only 512 mega of byte, 512 byte of are available for as a memory. 16C711 has 1024 or 1 kilobyte of the memory. 16F877, it has 8 kilobyte of memory. 17C766 has 16 kilobyte of memory. In examination, you may ask any type of the PIC microcontroller with any type of the memory. So you should cramp this type of memory size of the PIC microcontroller. So enough for this lecture. In the next lecture, I will tell you the new things about the PIC. So thank you for this lecture.